Okay students, welcome to another lab session. So today we will draw simplified representation of hexagonal headed bolt and the nut. In the previous exercise we have drawn the simplified representation of the external thread, that was without any the bolt head and the nut. Today we will add bolt head and the nut to that. According to the ISO standards, basically ISO handbook provides all proportions to the dimensions of the threaded fasteners, and the manufacturing companies follow those dimensions. For the drafting purpose, we will use minor diameter is equal to 0.85% of the major diameter, and the other dimensions we'll see in the next slide. So this is what we have to draw today. The proportions for the standard hexagonal headed bolt and the nut are given. They are slightly different for the heavy duty bolt and the nut. Now here if you look, this is your major diameter. This is a side view and this is a front view. So the major diameter is here. It will be given to you in the exercise. It may be different for every student. So everything depends on the major diameter. Look at the size of the hexagon. The hexagon size is 1.5 times the major diameter. The thickness of the hexagon, this here, the hexagonal head here, is 2 by 3 times the major diameter. The nut thickness is 7 over 8 times the major diameter. The thread run out is as before, 30 degree. The chamfer at the end is as before, like in the last exercise, 45 degree. There is one additional information here. This is the chamfer 30 degree for the bolt head. This bolt head is chamfered to remove the sharp corner, and that is taken as 30 degree angle for the drafting. And because of this chamfering, in the top view you can see the circle here, because you are cutting the sharp corners. More material is cut near the corners of the hexagon, and it is considered tangent here. The circle is considered tangent here to the hexagon. For this exercise we will assume the length as 80 millimeters. The total length from the including the head of the bolt to the end of the bolt is considered as 80 millimeter. We can assume any suitable value for that. We will assume 80 millimeters, and the threaded length we will take from the end to here 40 millimeters. Look at the situation arising because of this chamfering of the head. This is the head. This chamfering is 30 degree, and because of that in the top view you see this circular shape, and also you see this arc here on this face. There is an arc. We will see how to draw this arc in the front view and in the side view. So this arc is arising or coming here because of this chamfering effect. Let's take major diameter is equal to 20. From that we can calculate minor diameter is equal to 0.85 into 20, that will be 17 millimeters. All dimensions are in millimeters here. The width, this W here, that is 1.5 times D, that is the distance across the flats of the hexagonal head, that is 30. When we draw the polygon we will use half of 30, the radius, because AutoCAD is asking the radius of the polygon, so that is 15, because the distance across the flats is 30. Bolt head thickness will take 2 by 3 or 2/3 of the major diameter, that will come as 13.3, and the nut thickness is 7 over 8 times 20, that is 17.5. So we'll draw the front view. When we have to draw only one view for the bolt, we draw this position. In addition to the front view, when we need the side view, then we draw this view. Otherwise we draw this view. This is given as a first preference, because if you see here in this view, it looks like it will be similar to the square headed. So you can't distinguish if it is only one view, and if you draw it like this, you can't distinguish whether it is a square headed or hexagonal headed without the help of the top view. So let's start AutoCAD and draw it in the AutoCAD.